When astrophysicists confirmed TON 618's mass at 66 billion suns, it didn't just set a record, it raised a problem, because the universe has not existed long enough for a black hole to reach this size through any growth mechanism we currently understand. This is not a galaxy. It is not a cluster. It is one object, a black hole so massive it has broken the theoretical ceiling physicists calculated for how big a black hole can get. We are going to walk through exactly how large TON 618 is, layer by layer, until the number stops feeling like arithmetic and starts feeling like something else entirely. Then we will look at the physics that says it should not exist at this size, and the even stranger question of what it has become in the 10 billion years since that light left it. TON 618's black hole weighs 66 billion times the mass of our sun. Not 66 million, 66 billion. NASA cites this as the highest confirmed black hole mass ever recorded. To feel that number rather than just read it, start with our own galaxy. The Milky Way holds roughly 64 billion solar masses of stars. Every star you can see at night, every star in every arm of the spiral, everything. TON 618's black hole outweighs all of it, alone, with room to spare. Our own galactic black hole, Sagittarius A star, sits at 4.3 million solar masses. TON 618 is 15,300 times heavier than that. These are not poetic exaggerations. These are the measured figures in the peer-reviewed literature, confirmed by NASA and cross-checked against multiple spectral methods. The scale is real. Mass is abstract. Geometry is not. TON 618's event horizon, the spherical boundary inside which nothing, not even light, escapes, has a Schwarzschild radius of 1,300 astronomical units. 1 AU is the distance from Earth to the Sun. Neptune, the outermost planet, sits about 30 AU out. TON 618's event horizon stretches more than 40 times farther than Neptune's entire orbit. Its diameter runs to roughly 390 billion kilometers. At the speed of light, crossing that diameter takes 15 days. 15 days of uninterrupted light speed travel just to reach the other side of the shadow. To give that one more anchor, the Voyager 1 probe, humanity's most distant spacecraft, has traveled roughly 160 AU from Earth after 46 years of flight. It would not yet be at the edge of TON 618's event horizon. The geometry of this object is simply in a different category from anything in our neighborhood, and the physics of how it got here is stranger still. The light we use to measure TON 618 is 10.8 billion years old. That is older than Earth itself. When those photons began their journey, our solar system did not exist. The sun would not ignite for another 6 billion years. TON 618 lies at a co-moving distance of roughly 18.2 billion light-years, located near the border of the constellations Canes Venatici and Coma Berenices. What we are observing is the early universe in real time, a snapshot of conditions when the cosmos was barely a quarter of its current age. In that early era, TON 618 was not quiet. It was a quasar, a blazing active galactic nucleus, pouring out 140 trillion times the luminosity of our sun. That is brighter than the entire Milky Way by a factor that has no everyday equivalent. The accretion disk alone, the ring of superheated gas spiraling inward, measures roughly 1 light-year across. Gas in that disk moves at up to 10,500 kilometers per second. But here is what should stop you. It grew to 66 billion solar masses by the time the universe was less than 3 billion years old. There is a hard physical limit on how fast a black hole can grow. It is called the Eddington limit, named for astronomer Arthur Eddington. As a black hole consumes gas, That infalling matter heats up and radiates outward. At a certain accretion rate, the outward radiation pressure exactly cancels the inward gravitational pull, and the flow of new matter stops. That is the Eddington ceiling. In 2015, Professor Andrew King at the University of Leicester calculated a related constraint. Via pure accretion, no black hole should exceed roughly 50 billion solar masses before the accretion disk itself destabilizes and shuts off the feeding. TON 618, at 66 billion solar masses, sits above that number. Physicists now believe it required sustained periods of super Eddington accretion, consuming matter faster than the theoretical cap allows, combined with multiple galaxy mergers funneling fresh gas toward its core. The early universe was dense enough to permit this, but it remains one of the most uncomfortable numbers in modern astrophysics. TON 618 is not just large, it is larger than our best models cleanly permit as well. TON 618 is not just a black hole. It is a system, and the system is enormous. Surrounding the quasar is one of the largest gas structures ever catalogued, a Lyman alpha blob, confirmed by the Atacama Large Millimeter Array in 2021. This nebula stretches 330,000 light-years across. The Milky Way, for reference, is roughly 100,000 light-years in diameter. The nebula surrounding TON 618 is more than 3 times wider than our entire galaxy. It glows in ultraviolet light as the quasar's radiation excites the neutral hydrogen within it, producing the Lyman alpha spectral signature, the same wavelength emitted by hydrogen at 121.567 nanometers in vacuum. The nebula is also a star-forming environment, making TON 618 one of the most consequential structures in its corner of the early universe, not just consuming matter, but lighting up a gas cloud so vast it could birth entire galaxies. This object remade its local cosmos, and then, 10.8 billion years later, it went quiet, which raises the question of what it is today. The light we receive from TON 618 is a 10.8 billion-year-old postcard. The black hole itself has had all of that time to change, and almost certainly has. Quasars do not burn forever. As the surrounding gas is consumed and the galaxy mergers slow, the accretion disk thins, the radiation drops, and the active nucleus goes dark. Our own Milky Way is believed to have passed through a quasar phase billions of years ago. Sagittarius A star is its quiet remnant. TON 618 by now has very likely followed the same trajectory. It may sit today at the center of a massive, evolved galaxy. Its accretion disk cold and thin, its relativistic jets faded, its luminosity reduced to a fraction of what we observe in ancient light. Whether it has grown further in 10 billion years or plateaued near the maximum mass a spinning black hole permits is a question we cannot yet answer. The universe between here and there is too large to see through in real time. What we know is that this object, in the era we can observe, represents the upper edge of black hole mass, and possibly the upper edge of what physics allows. TON 618 was first photographed in 1957 on a plate taken with a 0.7-meter Schmidt telescope at the Tonantzintla Observatory in Mexico. Astronomers Braulio Iriarte and Enrique Chavira cataloged it as entry 618, a faint, oddly violet dot they assumed was a dead white dwarf in our own galaxy's halo. It was not identified as a quasar until 1970, when a radio survey in Bologna, Italy, detected unexpectedly strong emissions from the same coordinates. Astronomer Marie-Helene Ulrich then obtained optical spectra at McDonald Observatory, confirming the emission lines and the enormous redshift that placed it billions of light-years away. The name stuck, Tonantzintla 618, shortened to TON 618. As of 2026, NASA and peer-reviewed sources still cite it as the most massive confirmed black hole ever measured. The title is contested by a handful of candidates, but none has yet dethroned it with an equally direct measurement. What this object leaves us with is a clean, uncomfortable fact. The universe built something at the outer boundary of what our physics permits, and we found it by accident, thinking it was a dead star.